this practice we will know the conventional measurement instruments and their association with uncertainty. We will use a vernier, a digital vernier, a compass, a ruler, and a micrometer.
To use it is very simple. First, you have to put your bearing in this space. So you scroll this over and put the little bearing over here, and you scroll over again until it's fixed. Then you check these lines. So you have in here 3.75 because you have these little lines, and you measure every line measures 25 inches. So you have these 375, and then you have to check with these lines where the is more aligned with these ones. So in this is in 5. So it's 375 plus 5, so it's 380 inches.
Is the rule. Maybe the best measurement tool ever made. This is a piece of metal that has in here the centimeters and in here the inches. So you just adjust this to the part you want to measure, and you're going to get the length in centimeters and millimeters or in inches, that is in this part.
We use an electronic vernier to measure this bearing, and we put the bearing inside, and the value is shown here. This button can change between inches and millimeters, and this button is the on-off button.
This is the analog vernier. It's simple to use. You only have to scroll until the object is in the size of this opening. This is measured in millimeters. Each of these numbers are 10 millimeters, 20 millimeters, and with this you guide the measurement line.
Measure with the compasses is really simple. You will need obviously the compasses and also a ruler. First, you will need to open the compasses or close until you reach the size of the object. And once you reach this size, you will need to use the ruler and measure the little tips. In this case, it will be 3.7 or 8, something like that. Now we are going to analyze the results. For each tool, we measured 3 different times, 3 different integrants, the bearing. And with the micrometer, we got the 3 different measurements, and then we got the average and also the standard deviation. The average with the micrometer was 429 microinches and a standard deviation of 1.73. With the analog vernier, we got an average in the width of 1.1, an average of the external diameter of 3.5, and in the internal diameter of 1. And we got a 0 standard deviation. With the digital vernier, we got an average in the width of 10.98. In the external diameter, we got 35, and the internal diameter, we got 9.82 millimeters, and a standard deviation in the width of 0.01, in the external diameter of 0.03, and in the internal diameter of 0.12.
Now we are going to analyze the ruler, where we get an average of the width of 1.07 and a standard deviation of 0.06. Then the external diameter, we got an average of 3.4 and a standard deviation of 0. And in the internal diameter, we got 1.1 as an average and 0 in the standard deviation. Finally, we have the compasses, where we got an average of 1.2 in the width and the standard deviation equal to 0.1. the external diameter we got 3.53 as an average, and the standard deviation equal to 0.12, and the internal diameter finally we got 1.07 as the average and 0.12 as the standard deviation. If we analyze all the tools, we can notice that the best option for measurement in the laboratory is a digital vernier, because it is the most exactly tool that gives us the best value and the most real one.
At the end of this practice, we conclude that all the measurements were not the same. We have differences between the digital vernier, the micrometer, the ruler, and the compass. The most variation instrument was the ruler, because we can't have like the interspace between a number and another. We only have like the millesimo. The reason of the variations are that we're not like have the same view, the same side to between the ruler or something, like with some lines like the micrometer. And in our next project we will use the digital vernier, because for us was the perfect one, because gives you 2 decimals more than the other instruments.
I believe that the most efficient tool in order to measure the bearing was the digital vernier, because it was easy to use and also it was really exact. And the worst tool was the compasses, because you need the compass and also the ruler, so there is like more chance for you to make a mistake.
For me, the best option in the laboratory for measurements is the vernier, the normal vernier, because it's the cheapest one and gives you a value similar to the digital one. And the ruler definitely is the worst one. Also the compass. So I think the vernier, the normal one, is the best one because it's cheaper and is the second less and exactly.
In this practice, we established that the worst instrument was the digital vernier. The worst was the compass, because you have to use the ruler, and the ruler is not really an exact instrument, and have different measurements in of the bearing, because for example the rule the scale is not really an exact scale, and the compass you have to use the rule. And
I think that the best instrument for measuring the bearing was the digital vernier, because it was the most accurate, unlike the rule that it just throw numbers all over. I think it is because the different people that measure saw different numbers, and with the vernier, the instrument just gives the number to you.